Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. After your very good response for my Thermodynamics 2 lectures, I have decided to continue this thermodynamic topic. Thanks for your very good response. Today's lecture is lecture number 3. In this lecture, we will study how to change the internal energy of the system. Then first law of thermodynamics. Okay, let us start. Then we already studied that internal energy is the random disordered motion of the molecules of a system. That is called as internal energy. And the formula for internal energy is change in internal energy, that is nothing but NCV dt. N is number of mole, CV is specific heat of a gas at constant volume, and dt is rise in temperature. Means this internal energy depends on temperature only. Okay, and therefore the way first to increase the internal energy of a system is that supply heat to that system. For that purpose, consider this is a cylinder, and in that cylinder ideal gas is filled, and that cylinder is fitted with movable, massless and frictionless piston, so that there is no loss of heat energy. Understood? I repeat, consider a cylinder. In that cylinder, ideal gas is filled, that is the system, and that cylinder is fitted with movable, massless and frictionless piston, so that there is no loss of energy. Then this is the system, and remaining part, that is the surrounding. Ts is the temperature of the system, and remaining part T means Te, that is the temperature of the environment or surrounding. Then initially the system is at 100 degrees Celsius. When we supply heat with the help of burner to this system, then what happens? Temperature of system is less than the temperature of environment. Means Ts is less than Te. We already studied this case. At that time what happened? The heat is transferred from environment to this surrounding. To this system. This is the environment or surrounding, and heat transfer from this environment to the system. At that time Q, that is always greater than 0, that is nothing but A positive. But in this case what happened? The temperature increased from 100 degrees Celsius to 200 degrees Celsius, but the volume of the cylinder, that remains constant. And when volume of gas, that is constant, means change in volume is equal to 0, at that time work done is always equal to 0. Means you have to always keep in mind that when change in volume is 0, at that time work done is always equal to 0. Means heat supplied, this Q is the heat supplied, that is used to increase the internal energy of the system. Means for way first we can write delta U, that is equal to Q. This is equation number 1. Means we can increase the internal energy of the system by supplying heat to the system. This is the first way. Understood? Now we have to use this equation in the first law of thermodynamics. And when the volume of system remains constant, this is called the isochoric process. This is the isochoric process. Understood? And we can increase the internal energy by supplying heat to the system. Another case is there. When Ts is greater than T, what happens? When temperature of system is greater than the temperature of the environment, at that time by the system means Q is less than 0 means there is decrease in internal energy. Understood? When Ts is less than Te, then heat absorbed by the system, temperature of the system goes on increasing and internal energy of the system goes on increasing. And when the temperature of system is greater than temperature of the surrounding, at that time heat lost by the system, and at that time internal energy of the system that goes on decreasing. Then second way, how to increase the internal energy? Second way to increase the internal energy is that, again, this is the system. Ideal gas is there. System is fitted with movable, massless, frictionless piston, and this piston moves inside through distance d. This is the initial state and this is the final state. When the piston moves inside, at that time compression is done. Compression, that is nothing but work done on the gas. And when work done on the gas is there, compression is there, temperature of the system goes on increasing. Means initial temperature is 100 degree, final temperature is 200 degree. Means temperature goes on increasing, internal energy also goes on increasing. And in this case, the change in internal energy, delta U, that is equal to minus W. Because in this case, work done on the gas, and when work done on the gas is there, at that time negative work done is there. And this is the equation number 2. We have to use these two equations while obtaining the first law of thermodynamics. Understood? And in this manner, we can increase the internal energy of the system. First way, by heating it with the help of burner, and second way, by moving the piston inside, means when compression is there, internal energy also gets increased. These are the two ways. Now we have to study the first law of thermodynamics. First law of thermodynamics, that is nothing but relation between heat, work and internal energy. And therefore, first we have to study when positive work is done and when negative work is done. For that purpose, again consider a cylinder. This is the cylinder. Then that cylinder is fitted with ideal gas. That cylinder is filled with ideal gas, and it is fitted with massless, movable, frictionless piston. And now, what happened? Now, motion of the piston means, consider this is out of number of molecule, consider one molecule. And when this one molecule, this is one molecule, and this is the wall of the piston. Understood? This molecule having mass m. It is moving with velocity v in this direction. Understood? Then its momentum is m into v, vector v. That is the linear momentum. When this molecule collide or strikes with the piston, what happens? When it strikes with the piston, at that time that molecule lose its momentum, and its momentum gets lost, and the piston moves through some finite distance. Means it moves through finite distance and there is a loss of momentum, and the piston gain the momentum. Understood? And when it collide with that piston, and after colliding, that molecule travels in this direction, but its momentum, means mass remains constant, but its velocity gets decreased. Means its linear momentum before collision is always greater than its linear momentum after collision. Understood? And when compression is there, when this wall of piston travels some distance, means this is the motion of piston in this direction, then expansion is there, and when expansion is there, then positive work done by a system. Understood? Then second case, and therefore the length of this arrow, that is always greater than this arrow in positive work done by the system case. Then second case, what happened? Now again, this is the cylinder filled with ideal gas. It is fitted with the movable massless frictionless piston. Now motion of piston in this direction. When motion of piston in this direction and this molecule is here, when this the wall of piston that strike or collide with this molecule, at that time this molecule gain the momentum. In this case, molecule lose the momentum. In this case, this molecule gain the momentum and piston moves in this direction. Understood? And before the collision, this is the momentum, and after the collision, this is the momentum. Means before collision, momentum is less, and after collision, momentum is greater. But the momentum, that molecule gains the momentum, and a compression is there. And when compression is there, negative work done by a system is there. Understood? And in this manner, the positive and negative work done by the system. Now, we have to consider a third case. In that case, the volume of the system that gets increased. Okay. Again, consider a system. In that system, the A is area of cross section. A is the area of cross section of the cylinder or piston. Then P is a constant pressure then acting by the system on this cylinder, on this piston. Okay, P is the pressure exerted by the system on this piston. Then the force is, we know that P that is equal to F by A, and therefore F that is equal to P into A. This is a constant force acting on that piston by this system. Understood? And now we have to displace this piston through distance dx. Means force applied on a body produces a displacement. At that time work is done, and this constant force acting on this system. Then work done. When displacement is dx, at that time work done is dw, and work done, that is nothing but the force into displacement. Then value of F that is equal to P into A, and area into displacement, that is nothing but change in volume, and therefore the work done when we displace this piston through distance dx, at that time a small work done is there, and that work done is dw, and dw that is equal to P into delta V. Now when the volume goes on changing from value Vi to Vf. Vi is initial volume and Vf is the final volume. At that time total work done that is equal to, that work done that is nothing but integration of dw within the limit Vi to Vf. Okay. Now substitute value of this dw, Vi to Vf. Value of dw that is P into delta V. Pressure is constant, and therefore now taken outside the integration sign. Vi to Vf dv. Integration of dv that is nothing but V. Now apply the limit. By applying the limit we can write W that is equal to P into Vf minus Vi, and this is the total work done when the volume of the system goes from changing value Vi to Vf. Understood? And this is the work done. Now we have to calculate the mathematical statement of a first law of thermodynamics. Just now we studied that first equation, delta U that is equal to Q. This is way first to increase the internal energy. At that time work done is 0. And second way, delta U that is equal to minus W. That is second way to increase the internal energy. Combining these two equations, we can write delta U that is equal to Q minus W. This is equation number 3, and that is nothing but the mathematical statement of a first law of thermodynamics. What is this statement? From this mathematical statement, we can state the change in internal energy of a system is equal to difference between the heat supplied to the system and the work done by the system on the surrounding. Understood? I repeat. Change in internal energy is always equal to difference between the heat supplied to the system and the work done by the system on the surrounding. We can write this equation in different form. That is nothing but Q that is equal to delta U minus plus W. Means heat supplied to the system, that is always equal to the change in internal energy, and remaining is lost for the work done by the system. And this is the alternative statement of a first law of thermodynamics. Okay. First law of thermodynamics is nothing but the law of conservation of energy. Understood? Always keep in mind that because internal energy, it is a form of energy. Q is heat, that is also form of energy, and work done is stored in the form of energy. Means this is nothing but first law of thermodynamics, that is nothing but the law of conservation of energy. Okay. Now we have to study when internal energy is positive, when internal energy is negative, and when internal energy is zero. Now consider the system. In this system, the Q that is equal to 200 joule and W that is equal to 100 joule. Then formula for internal energy, that is equal to Q minus W. Q is 200 joule and W is 100 joule, that is equal to 100 joule. Means delta U is positive. When Q is greater than W, at that time change in internal energy is always greater than 0 or positive. This is the first case. Understood? When the heat supplied to the system is always greater than the work done, at that time change in internal energy is always positive. Then second case, when suppose Q that is minus 200 joule, W that is equal to minus 100 joule, at that time Q is less than, means minus 200 minus plus 100, it becomes minus 100, means Q is less than W. At that time delta U is less than 0, means it is negative. Understood? And this is the second case, means heat supplied to the system is less than the work done by the system. At that time change in internal energy, that is always less than 0, that is nothing but negative. And third case, when Q that is equal to 200 and W that is equal to 200 joule, at that time when Q that is equal to W, at that time 200 minus 200 that is equal to 0, means third case Q that is equal to W, at that time change in internal energy, that is always equal to 0. Understood? I repeat, when Q is greater than W, change in internal energy is positive. When Q is less than W, change in internal energy is negative, and Q equal to W, change in internal energy, that is equal to 0. Means the heat can be positive or negative. Then work can be positive and negative, and change in internal energy also it can be positive and negative. And this is all about the first law of thermodynamics. I hope you like this video. If you like this video, then like, share, subscribe it, and also press the bell icon so that you will get the new identification of my new videos, upcoming videos. Thank you very much.